Okay, good morning, everybody. After such a wonderful welcoming introduction to this session and such a wonderful panel, it's a hard hack to follow, but I'm Sylvie Garneau-Tsodikova. I'm from the University of Kentucky, and today I'm here to discuss with you some new compounds as potent antifungal agents. And you might be wondering, antifungal agents, why would we need antifungal agents? Fungal infections are not problematic. Well, actually, fungal infections can be deadly. And not only can they be deadly, we're in dire needs of new treatment. In the past few years, there have been headlines in the New York Times such as a mysterious infection spanning the globe in a climate of secrecy. Well, fungus infections are not secret. We all know about fungal infections, but a lot of us don't know that they can be deadly. You can see this other headline: to fight deadly Candida auris, New York State proposes new tactics. Candida auris has been growing in terms of the resistance to it. And I have one of my students that's now working in New York to try to fight this Candida auris epidemic. Not only that, in the past few years, we've all experienced COVID. Hopefully not too many of us have gotten sick. I have, but I didn't get the fungal infection that has been exacerbated by COVID. You can see here how COVID-19 created a perfect storm for deadly fungal infection in India. So the climate we're in is really a climate where we need new antifungal agents. And just last week, you can see here October 25, the World Health Organization flagged fungal infection as a global health threat. Now, you might still not be convinced and might still say, I don't think fungal infections are that bad. And if that's the case, you're probably thinking about the ones that are superficial, that affects your hair, your nail, your skin, like the ringworms and athlete's foot. But that's not what we're interested in. We're interested in systemic fungal infections. Those are the ones that affect organs like the brain, lungs, heart, liver, spleen, and kidney. You might not know these affect millions of people every year worldwide. And just pause for a second and listen to this very carefully. More people will die from the top 10 invasive fungal diseases than from TB and malaria. So I was just talking with our person from Toronto that's really interested in malaria. So be interested in fungal infection too, please. So more people will die from top 10 fungal infection than from TB and malaria. And not only that, the mortality rate are staggering. There are some fungal infections that affect up to millions of people every year. And the mortality rate for these fungal infections can reach up to more than 90% in the infected population. So a lot of people will die from these systemic fungal infections. You might say, well, Sylvie, we do have current antifungals on the market. Yes, we do. But there are problems associated with these antifungal agents. They're toxic. That's one problem. But more importantly, just like every microbes, the fungal strains have developed resistance to our current antifungal that we have in our toolbox. But don't worry, we have solutions. So we have, I'm just showing you one family here, but we have a small portfolio of antifungal agents. And the one that I'm going to show you today potentially has new mechanism of action. So we just heard from the panel, what's different about your products? Well, these might have a new mechanism of action. Our current antifungals have no mechanism of actions, and our compounds don't work through these mechanisms of actions. We know that. We don't know what the mechanism of action is, but we know that it's not the ones from the current antifungal. We call those ha, like ha-ha moment. So don't worry about the big name. Just remember ha, and you'll be in good shape. And we have patent on these. Now, this is a lot of data. You don't have to worry about looking at all of these. All you need to know is green means good. And it seems like green doesn't show up very well on this slide, but there's a lot of green. And as James just told me 2 minutes ago, green is good like money. So I'm listening to James. So see, I'm very teachable. So we have, these agents are broad spectrum. They work against the deadly C. auris, the resistant strains actually. They also work against Aspergillus and Cryptococcus, which are different types of fungal strains. They have high potency as low as 0.6 microgram per mil. Now, I just heard from Chris that I should have kept all my data slides. I've been told by my tech transfer person to remove them. So they're summarized in bullet points. So in addition to being very potent, They're really easy to synthesize, high-yielding, few synthetic steps. In contrary to the current antifungals, we don't see resistance develop to these compounds after many serial passages. So that's a good point as well. We don't see cytotoxicity against mammalian cells. We don't want to destroy your blood. So these compounds are not hemolytic, which is good. And we for sure don't want to affect your heart in a bad way. So they don't display hERG activation, so they're not cardiotoxic. Where are we now? Well, somebody on the panel said you should have animal studies. Sorry, I don't. I wish. But that's where we're going now. We need to go in animal to get some PK/PD bioavailability studies. And I told you we don't know the targets yet. So we're working real hard to figure out what the target of our compounds are so that we can further optimize them in a more rational way. These have good properties needed for IND status. They have opportunities for accelerated FDA review to gain act in LP80 pathway. Now, do we have competitors? Yes, we do. And that's great, right? We just heard that. So we have other people that are trying to develop antifungal agents. But what's beautiful about it is that their antifungals have completely different structures than ours. And the mechanism of actions of these compounds are mechanism of action that are already mechanism of actions of current antifungals. So they probably could develop resistance, or the resistance could develop to them much quicker probably than to our compounds. The market for antifungal is pretty stable, as you can see, slowly growing from 12.5 to 17.2 billion dollars. And I am almost running out of my 7 minutes. So who are we? We are a collaborative team that has for aim to fight infectious disease health threat. As I said at the beginning, I'm Sylvie Garneau-Tsodikova. I'm a professor at the University of Kentucky. I'm a medicinal chemist by training. My friend, Professor David Watt, brings the translational research aspect to the team. And Nishanta Banchandrika is the research scientist who has generated all the data for this project. And I will leave you with one slide, and that's the most important slide. Just remember that. They say an apple a day keeps the doctor away. And I hope that one day soon, with help of everybody that has a lot more knowledge than I do, you'll be able to say, oh, I have a fungal infection. Sylvie's Haas compound will be able to keep my fungal infection away. So if that's all you remember, and one day you have the Haas compound, you'll be able to cure your fungal infection. Thank you for your attention. Happy to take any questions.
Any questions?
How do you come up with these compounds? I mean,
yeah, so we are a team that is interested in fungal infection and bacterial infection. We're medicinal chemists, so we develop compound at large. And originally, these compounds we thought could be good antibacterial agents. They turned out to be much better antifungal agents. So it was kind of serendipity because we do some development against specific target. But as I said, we don't know the target of these ones because they were not developed specifically to be antifungal. So this was serendipity. We have other compounds that are gold-based compounds that are also really good. And we have some compounds that have similar mechanism of action than those that the competitors are developing because they were developed towards these target that are already existing. But those were serendipity. Yeah.
Just following up on the question about mechanism, you mentioned that it's not known, but based on your knowledge or maybe your suspicion, do you think this is a host-dependent mechanism or is it a fungal protein origin in terms of mechanism?
I hope it's a fungal origin because then it's not going to affect the host in a negative way. So what we're doing right now, we're doing a few different things. We're looking at pull-down assays to try to figure out the target. We're developing some compounds that are fluorescent, also to look by fluorescence microscopy. And we are also trying to develop resistant mutant in the fungal strains. So there are libraries already of fungal like mutants where you can try to figure out what your compound targets. This has not been really successful. We've just given it one trial, but we're trying to develop resistance mutants as well. So we're looking for a target in the fungal strain at the moment. And I didn't know where the question came from, so I'm not looking at any, oh, sorry. I was not looking at anybody specifically because I couldn't figure out in the room. So does that answer your question? Awesome.
Perfect timing.
We can talk. Thank you so much.